My name is Guruprasad Pujari. Today we will see the energy density in electrostatic field. First of all, we will see the energy density definition. Energy density is the amount of energy stored in a given system or a region of space per unit mass. As we seen from diagram, we can find the energy density from given shape. Now, consider a point charge Q1 transferred from infinity to position R1 in this system. It takes no work to bring the first charge from infinity since there is no electric field to fight against them. Therefore, system is empty or charge free. Hence, the total work done is a 0 joule. Now bring the another point charge Q2 from infinity to position R2 in the system. The diagram is as shown. In this case, we have to do work against the electric field generated by the first charge Q1. Hence, W2 is equal to Q2 into V21, where V21 is the electrostatic potential at point R2 due to Q1. Therefore, work done at plus 2 is equal to Q2 into Q1 divided by 4 pi epsilon R2 minus R1. Now, and the work required to bring Q3 to a distance R13 from Q1 and distance R23 from Q2 is W3 is equal to Q3 V31 plus Q3 V32, as Q3 take common, Q3 into V31 plus V32, where V31 and V32 are electrostatic potential at point R3 due to Q1 and Q2 respectively. The work done is simply the sum of work done against the electric field generated by the point charge Q1 and Q2 taken in isolation. Therefore, Q3 is equal to W3 is equal to Q3 Q1 divided by 4 pi epsilon R3 minus R1 plus Q3 Q2 divided by 4 pi epsilon R3 minus. Thus, the total work done in assembling the three charges is given as total work done is equal to W1 plus W2 plus W3, that is equal to 0 plus Q2 V21 plus Q3 into bracket V31 plus V32. Also, total work done W is given as W is equal to, as 1 upon 4 pi epsilon takes common, 1 upon 4 pi into bracket Q2 Q1 divided by R2 minus R1 plus Q3 Q1 divided by R3 minus R1 plus Q3 Q2 divided by R3 minus R2. If the charges were positioned in reverse order, that means the point charge traveled from infinity to at position R3, then the work done W3 is equal to 0 and W2 and W1 taken as with respect to W3. Then the total work done in assembling them is given as W is equal to W3 plus W2 plus W1, that is equal to 0 plus Q2 V23 plus Q3 into bracket V12 plus V13, where V23 is the electrostatic potential at point R2 due to Q3, and V12 and V13 are electrostatic potential at point R1 due to Q2 and Q3 respectively. Adding the above two equations, we have 2 times of total work done is equal to Q2 into bracket V12 plus V13 plus Q2 into bracket V21 plus V23 plus Q3 into bracket V31 plus V32, as V12 plus V13 is equal to V1, V21 plus V23 is equal to V2, and V31 plus V32 is equal to V3. Therefore, equation becomes 2 times of total work done is equal to Q1 V1 plus Q2 V2 plus Q3 V3. Hence, total work done is equal to 1 half of Q1 V1 plus Q2 V2 plus Q3 V3, where V1, V2, V3 are the potential at position R1, R2 and R3 respectively. Then the result can be generalized for n point charges as W is equal to 1 half of summation k is equal to 1 to n Qk into Vk. The above equation has three interpretations. First, this equation represents the potential energy of the system. This is the work done in bringing the static charge from infinity and assembling them in required system. And last one, this is the kinetic energy which would be released if the system get dissolved, that is the charges returns back. In place of point charge, if the system has a continuous charge distribution, that is line surface and volume charge, then the total work done in the assembling them is given as, for a line charge, W is equal to 1 half of line integral of rho L into VDL. For a surface charge, W is equal to 1 half of surface integral of rho S into VDS. And for volume charge, W is equal to 1 half of volume integral of rho V into Vd. Since rho V is equal to del dot D and E is equal to minus del dot V, substituting the values in the above equation, work done in assembling a volume charge distribution in terms of electric field and flux density is given as W E is equal to 1 half of volume integral of D dot E into dV, that is equal to 1 half of volume integral of epsilon E square dV, because D is equal to epsilon E. The above equation tells us that the potential energy of a continuous charge distribution is stored in an electric field. The electrostatic energy density WE, also defined as W is equal to 1 half of epsilon E square, and W is equal to volume integral of WE into dV.